In this first problem, we are told that when a concert charges $6 per ticket, they sell 100 of them, and they find that for each $1 increase in price, they sell 10 less tickets. And we're asked to find the ticket price that would yield the maximized revenue. What is this maximum revenue, and how many people will attend when they have maximum revenue? So throughout this video, we're going to be using this formula that revenue is equal to price times the quantity sold. So for example, if you run a lemonade stand and you charge $5 for every glass of lemonade and you sell 10 glasses of lemonade, then you're going to have a revenue of $50. So let's write the equation at the baseline for the concert. So the revenue at its baseline is going to be $6 for every one ticket that they sell, and they're going to be selling 100 tickets at that price. So their baseline revenue is going to be $600. But in this problem, they make some changes. And each time they make a change, we're going to see a different price and a different quantity sold. So we're going to let x equal the number of times they change the price. Okay, so let's see what happens. We're going to have an increase. Every time they change the price, that's x, you're going to have an increase of $1. And in terms of the quantity, every time they change the price, you're going to have 10 less sold. So folks, this is the equation that we're going to be working with. So let me go ahead and fill in the original price and the original quantity. So instead of P here, I'm going to have 6, and instead of Q, we're going to have 100. So we're going to have 6 here and 100 here. Okay, if we FOIL this out, we get the following. We get that the revenue is going to equal negative 10x squared plus 40x plus 600. And if we factor out a negative 10 out front, we're going to get x squared minus 4x minus 60. And when we factor that, we're going to get negative 10 times x minus 10 times x plus 6. Now, whenever you have one of these problems where you see the word maximum, that means you're looking for the vertex. You might see the word minimum, in which case you're also looking for the vertex. But that's the clue that the vertex is going to be part of the problem. So let's go ahead and find the vertex of this problem. We're going to use negative b over 2a. And when we use negative b over 2a, we're going to get negative 40 over negative 20 for a vertex of x equals positive 2. All right, so let's talk about what that means when x equals positive 2. And let's get the y-coordinate of the vertex also. If we do f of 2, if we plug in 2 here, we're going to get a y value of 640. So I'll let you work on that on your own. Okay, so let's put this together in a graph and see what we have. We have the following. Along the y-axis, we're going to have revenue as a function of x. Okay, so we're going to have x down here. X is the number of changes that are made. And this is going to be revenue as a function of x. So when we solve each of these factors for 0, we're going to get x-intercepts at negative 6 and at positive 10. And we're going to get a vertex when x equals 2. And the y-coordinate of that vertex is going to be 640. So we're going to get a graph that looks like this. Okay. Now, what does this mean? Let's rewrite the equation that we had. where the revenue as a function of x is going to be 6 plus 1x times 100 minus 10x. Okay, so here we see that when x equals 2, this revenue is going to be maximum. So what is the price? Well, the price goes from 6 to 6 plus 1 times 2. 6 plus 1 times 2. So when the price equals $8, then we will have maximum revenue. What is that maximum revenue? We already have that. That's $640. And in terms of answering this question, how many people will attend? Well, we're going to set x equal to 2 here, meaning there's going to be 2 changes. So you're going to have 100 minus 20, or 80 people will attend. Folks, let's now do this same exact problem, but we're going to do it a different way. Again, whenever we see the word maximum, we want to think about the vertex, so we need a quadratic equation. So in this particular technique, we're going to take the quantity as a function of p, and then we're going to plug it in here, and when you get p times p, we're going to have our quadratic. So we want to create a function, a linear function, where we're going to have a slope times the price plus b. So in essence, we're going to have, along the x-axis is the price, that's your input, and here it's going to be quantity as a function of the price. Okay, in order to get the equation of any line, we need 2 things. We need the slope and we need the y-intercept. We're going to use this data to get our points. So if you have an input of price here and an output of quantity, we're going to use this first data point, that when the price is $6, the quantity sold is 100. Then when we increase the price by $1, so now the price jumps to $7, the quantity sold drops by 10. Folks, these are our 2 points. We're going to do the change in y over the change in x, and we're going to find that our slope over here down in the lower left corner is -10. In order to now find the y-intercept, we're going to plug in either of these 2 points. So let's plug in the first one. So we're going to have 100 equals -10 times 6 plus b, your y-intercept, and we're going to end up with a b value equal to 160. So our final line, Q of P, is going to be equal to -10p plus 160. Okay, folks, we're now going to plug this function into Q. So our revenue now is going to equal P times -10p plus 160. That's going to yield -10p squared plus 160p plus 0 if you'd like. If we do -b over 2a, we're going to get -160 over -20, and that's going to equal +8. So, price of +8 will maximize this revenue, just what we got before. And then to go ahead and get the number of people, we would plug this in for the price, and I'm sorry, this should be a p. We would plug this in for the price, and if we plug in p equals 8, we will see that the quantity is going to be -80 plus 160, or 80. And then if we wanted to do the revenue, we would plug in Q equals 80, or excuse me, we would just plug in P equals 8 here to get the revenue. We would get 8 times 80, or 640, which are the exact values that we got doing it the other way. In our next problem, we are told that when a stadium charges $30, the attendance, or quantity sold, is 400, and for each dollar decrease in price, the attendance increases by 50. So folks, we're going to use this revenue equals price times quantity. In this case, it's price times attendance. And we're going to find Q as a function of P. Because then when we multiply P by this expression, which is going to contain P, we're going to get P squared and have a quadratic function, and then we can find the vertex, which is always the goal when you see words like maximize or minimize. So let's go ahead and get the linear expression that relates the quantity to the price. The price will be the input here, and Q of P on the y-axis would be the output. So we're given some points here. So let's create our table for an input, which is the price. The quantity is going to be the output. So we know that when the price is $30, we have 400 in attendance. And when we drop it down $1, we have a increase of 50 in the attendance. So first we're going to get the slope. The slope is going to be the change in y over the change in x. That's going to be negative 50. So with a slope of negative 50, we now need to find the y-intercept of this line. We can plug in either of these 2 points to get that b value. So let's plug in the first point. So we have an output of 400 when our price is at 30. So you're going to have 400 equals negative 1500 plus b, and eventually you're going to get a b value equal to 1900. So folks, we're going to combine the slope of negative 50 with the y-intercept of positive 1900, and our new expression for Q as a function of P is going to equal negative 50 times P plus 1900. Okay, we're now going to go ahead and plug this in for Q to get our quadratic function. All right, let's do that over here in white. When we plug revenue equals P times negative 50P plus 1900, and we multiply that, we're going to get that the revenue equals negative 50P squared plus 1900P. Okay, we're asked to find the price that maximizes the revenue. This is a function now where the revenue is a function of P. So here we have revenue as a function of P. Here we have an input of P. So we just need to get negative B over 2A. And when we do that, we're going to get negative 1900 over negative 100, or a price value of 19. So when the price is $19, our revenue will be maximized. Now, if they want the revenue, we can just do revenue as a function, we'll just do R of 19, and we would plug in 19 everywhere you see a P, and the revenue would come out to $18,000.50. If they want the quantity, meaning the attendance at the maximal price, we would plug in 19 for P here and as the price, and when we do that, we get a quantity of 950 people in attendance. So in summary, the maximum revenue, which will be this value, will occur at a price of $19 and an attendance of 950.